Hello, this is the Tepid Coder. Today, I want to go over some more C++ class stuff. There's something I've been kind of avoiding talking about for a while. It doesn't really have an immediate obvious use, but it will eventually, and I think this is the eventual time. Hands are kind of not feeling great today. Okay. Yeah, typing's going to be difficult. Okay, standard int h. Let's do types of h, just usual stuff. I mean, I could be a little bit lazier here, maybe just omit that and do format. Maybe I should do that from now on, I don't know. It is a lot more to type, but probably a better way to do things. Okay, so anyway, let me show you some more class stuff today. In particular, I want to talk about having some type. You have a type pointer, and you also have type reference like this. TX, let's say. So I'm going to use a real type here. Let's say char. Okay, and let's say I have a character C equals letter C. Well, what you can do with this is if you say you have a reference to something like this, you can set it equal to something of the type you're referencing. So it references one of these, so I need to reference a char. This is a char type, so I can set it equal to that. So it will be a reference to that. What happens is, this basically gets treated like an alias to this. Whenever I manipulate this variable, it's going to manipulate this one. Whenever I read from this variable, it's going to read from this one. So I'll just show that real quick. I'm going to say, I also need, I guess I don't need IOStream because I have, I'll use it though. Let's do this completely C++ like, IOStream. Right, this will give me cout, right, and cn. This will give me standard string, standard w string for charts, right? This would be for char, oops, char, not char. This is standard, the format I'm going to use. Okay, anyway, let's do standard cout. We're going to do standard format. We'll even do standard end line, even though it's faster actually just to put the line break like this. Okay, C, it's going to be that, whatever's in here. Okay, so into cout, we're going to push some value. It's going to be whatever I format here. After that, I'm going to push a line break. Okay, so I have the format string. Now I need standard make format args. What do I want to put in there? I want to put in, let's say, C. So you can see I set C to the letter C. I said this now equals C. Now I'm going to say tx plus plus. So the value that this holds is going to increment by 1. Right now, this is referencing this. Whenever I mess with this, it's going to mess with this instead. So this variable right here is going to become one higher, which is a D. A, B, C, D. Dot, dot. So C becomes D. Right here. Maybe I should actually paste that here. Okay. Right. What can I say here? I think I'm going to break this down to the next line. Make it a little bit easier to read. Argument 1 here. Argument 2 here. Okay, like that. Then we're going to append next line. Okay. We need to return 0 from the main function. And I will get into the class thing in a second. But this is kind of a preamble to it. Okay. Actually, I don't want to compile it here. I'm going to compile it in the PowerShell. Oops. Let's see, plus test.cp output test. Okay. Doesn't know what vformat is because I need to use standard C++20. That's when vformat came out. So standard std equals C++20. Now it should work. Standard equals 20, not 10. Oops. There we go. So C is printing a D, like I said. So I'm going to get rid of these two lines here. And I'll print it as it was. It should show a C, right? So clear it. Boom. Now the C. So that's what a reference does. You're basically aliasing something. Now, this can be nice sometimes, but sometimes it's confusing why you'd want to do this, right? For something like this, why not just use C, right? Why have a reference like this? So I'm going to show an example of why you might do that using a kind of convoluted nesting of containers. So I'm going to include, say, vector, Now what I'm going to do is I'm going to say I want, oh, I'm putting a hashtag there, standard vectors of characters. Okay, so PV, let's say vector of vectors, we'll call it characters. All right. So what I'm going to do here is I'm going to say, I'm trying to think what I should put in here. I want to make this kind of a complicated example because you can imagine for each of these vectors, say VV characters, I called it, if I access the 0th element, what that's going to give me is a vector of items. It's going to have like a vector 0. It's going to have its own list of items, 0, 1, 2, 3, whatever. And then vec 1 inside of here, the second element, it's going to have, you know, its own 0, 1, 2, 3. All these are elements, right? So the elements of this outer vector right here, that thing, is going to be this, which has a list of vectors. And this list of vectors inside of it is going to have a bunch of characters. So really it's more like, you know, this, but I'm just talking about the indices right here, indices rather. Okay, so I just want to make something like that. And what I'm going to say is, let's see here, for sti equals less than, say, 10. Let's make 10 vectors. And each time what I'm going to do is I'm going to say create a standard vector of characters, the kind I'm going to put inside of the outer vector. So I'm making one of these to stick into this, which takes this as an element type. So D, I'm going to say, this is a vector, right? Vector of characters. So vector of characters is a vector of vectors of characters. Okay. So now I'm going to say v characters dot, let's say, place back, and that's what I want to do here. I don't know what I'm going to do. This will work. So I'm going to make a const character pointer to a string, which is going to be immutable. I'm going to say alphabet equals, I'm going to say, you know, A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, U, X, Y, Z. I might have screwed up typing that, but I don't care. So what I'm going to do here is every single time I run through this loop, I want to say S for start equals LPSC alphabet. So I'm going to start at the beginning of the character, it's here. And what I'm going to add to it is STI. So it starts at 0, so I'm going to start at A. I'm adding 0 to it. The next time I'm going to add 1 to it, so it's going to be B, and then C, and then D, all the way up to the 9th character, which would be I believe. J is the 10th letter of alphabet. So actually don't on J, right? Because this is 0, and I'm going up to 9. So this will be the 9th element. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it'll end there because the 10th is where it stops. It'll be the K. Okay, so A through J the first time, then it'll be B through K, and then C through L, and then so on and so forth. Okay. Okay, then let's say const char E for end, let's say equals S plus 10. So at most, I'm going to have 10 plus 10. So 10 starting at K, right? Because J would be the 9th if it's 0 indexed. So here plus 10, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is the endpoint, so it'll be K to T, should be the last cluster. Okay, so now what I'm going to do is I'm going to insert back to v characters dot end. So this new vector I just made, that just holds characters right here. At the end of that vector, I'm going to insert everything from S to E. It's up to but not including, right? This is going to include, or to insert rather, S comma E, this range. So it's not inclusive. Okay. Yeah. And then what I'm going to do is after I've inserted that, I'm going to say that this is going to get inserted into the bigger vector of vectors. So EV characters, vector of characters, dot in place back, and we're going to say, how about standard move v characters. Now, the reason I'm doing standard move here is I don't need this vector to continue having these elements, because as soon as this vector right here goes out of scope, which will be the next time the loop runs, starts here, the scope ends here, this is going to get deleted anyway. So instead of copying everything into here, the vector of vectors, I'm just going to move the vector of characters into the vector of characters. Okay, now what I want to do is I'm going to say for const auto, let's say v, take elements of the vector of characters. Okay, and then inside that we're going to have another loop that says something like, I don't need to do that actually, I could just say character pointer. I'll make it a constant character pointer. It has to be because it's constant. Each time I'm going to get this. That's a copy. I need it to be a reference. So each time I'm going to get standard vector char that. If I did this, it would be that. It would be a copy. I don't want that. I want this to come out. That's what v is. But it's const, right? Because I marked it as const. And if that's const, that means the characters inside have to be accessed like they're const as well. Not const. Okay. Anyway, I'm going to say, let's just p, okay, equals v.data. So remember, I'm talking about a vector here, vector reference, v.data. Okay. So that's going to give me the pointer to the first character, which should be like A, then it'll be B, then it'll be C, all the way up to K, because it goes up to 10. Okay, and I'm just going to say standard cout, we're going to say P, and we're going to say standard line. Actually, I want to put this in quotes. Like that. Okay. I'm escaping the quote there with the backslash. Let's just see what that does real quick. Okay. So this is going to be a bit annoying probably. Array must be initialized with break. Oh, I defined an array of pointers. I don't want an array of character pointers. I just want a character pointer to this block. Or it could just be a constant character array of this block. So that was silly. Anyway, let's do that. Okay, what else do we have going on here? Trait, so it doesn't like the way I created the vector probably, so I'm guessing. Where is it actually required from? It just says required from here. Okay, so line 24. Let's look at that. Line 24, what did I do weird? So in place back. Oh, what am I doing? Jeez, insert. In place back, take a single element, like v characters in place back. What I could do is I could just stick a single like c in there. It would add the character c to this vector of characters, right? That's what that's for. But in place back can also do a move operation. If this were actually a class type that could be moved with, you know, standard move, which we'd call the move constructor. I showed that in an earlier video. Then we'd call the move constructor and put that in here. And if I actually created the object here, like say I have some, I don't know, some class, you know, I take some arguments for its constructor, right? Instead of typing that, I could just actually type the argument of the constructor. It would make the class and then move it in here automatically. So in place back's pretty nice, but insert you can put more than one element based on a range. Okay. Now it compiles. It's happy. You can see A through J. Why is there a backslash in there? There's a P. I've done something weird here. So A, B, C, D, E, F, G. Oh, I never actually inserted a 0 at the end, right? So when you print stuff out with cout like this and it's a constant character pointer, it is trusting you to have a 0 terminator at the end, which I did not insert. So what I really should be doing here is at the end, I do v characters. And I'll use in place back, like I was talking about earlier. In this case, I'm going to insert a 0, which is that character, right? That's how a lot of people write it, but it's the character 0. Doesn't really matter. Okay. Okay. There we go. Now it works. A through J like I thought, and it shouldn't. Oh, it's J to S. I thought it would be K to T, but yeah. Whatever. So now, how does the reference come in here? The aliasing. Well, what I want to show is, instead of saying something like, I don't know, dv characters position 0, position 1, right? So if I'm referencing the 0th vector of characters, it's the one that holds A, B, C, D, E, F, whatever. The second one would hold B, C, D, E, F, whatever. So I want the one that starts with A, and I'm taking the second character of it. Now if I did 0, it'd be referencing the A. If I did, you know, right? And if I do 1, it's going to reference the B inside that vector. So that's what this is right here. But what if you want to make it a little bit easier to access this? Because it's kind of confusing if I'm accessing characters, let's say 3 and then 0. What I might want to say is something like, I want the vector character vector that starts with A. I can reason about that more easily. I say the second one, or the second index would be 1. This would be third index. So 0, 1, 2. So it should be C equals C, right? And I can actually kind of alias like this by saying something like standard vector of characters reference that equals, I'll bring it on to the next line because it's pretty long. And I'm going to say it equals vector of characters position 0, right? If I want, I can say the one starting with B is going to be equal to the second vector, right? So then instead of saying 0, 1, I could look at this thing that I've named cleverly position 1, right? And this one I could say B starting at position 3. Okay. Oh, I said 3 there, which would be the fourth one. So A, B, C, D is what that was, and position 0. Right, that should be a D. A D. So let's try and print these out. I mean, even this isn't a great example, but if I hadn't typed the name this long, you could see it would be less typing and more clear what you're doing. I can give another example that'd be probably helpful for aliasing. But first, yeah, let's just print it out. C out. And I'm going to say line. Bring to the next line. I'll leave it like that. But let's also say before that, let's say vector starting with A. It has some character. Yeah, and over here I want to end that in line. Yeah. Now let's do the same thing over here. This time it's starting with D, or it was D, 0. Okay. So I'm thinking we're going to print a B here. And then we're going to print a D here. Let's see if that works. Well, I messed up. Line 47, missing a semicolon. 7. Right there. I missed that little concatenate token. Okay, line 53. Same thing because I copied and pasted it. Copied and pasted it, rather. Okay. Okay. I said B instead of D. I defined it. Okay. Is it D? So I'm looking. Okay. I guess I changed my mind at some point, made it the second element of the array, which is index 1. But I wanted the D earlier. It would be A, B, C, D, which is the fourth element, which is the third index, index 3, right? So let's try that. Okay, we got B, we got D. I didn't write that right. D. Okay. So yeah, vector starting with A, I took the index 2, which is second element, and then vector starting with D, I took the 0th element, which is D. So starting with A, took the second element, index 1. Vector starting with D, started here, took the 0th element. So that's kind of nice. Now there's, I'd say, situations where this makes sense to do. I'm going to comment this out differently, because you can't have nested blocks of comments like this, with slash asterisk and asterisk slash. In fact, I was going to take this out, actually. Let's wipe all of this out. Let's just put it in like a void test or something. Test function. Boom. Okay, now there's another type in standard templates for C++ called map, and this can take 2 templated arguments. And what you can do is you can say, when you access this, there's like a key and a value. So let's say I have map m. If I say map position key, it will actually give me the value. So this value is a type, right? Let's say, I don't know, I enter a character, and it gives me a character back. So let's say I ask for an A, and I say char C for character equals position A. So it's going to have like a list of keys, you can imagine. Like imagine you have two arrays here. One's of keys, and one is values. Okay. Let's say the keys are something like a B, C. Okay, and then you have values associated with each of these keys. So imagine this is each associated with, these are each associated with a different value. So maybe A is going to be C, and B is going to be Z, and I don't know, if you ask for a C, it's going to give you a 7. Like not the value 7, but the character 7 in the ASCII symbol set. So right now I'm asking for an A. Maybe I expect to get a C back from that, so C is going to be C. Okay, so what you can do once you make this map is you can start assigning these values. I'm going to say, so if I have map A, I'm going to assign it to the value C. So when I ask for an A, it's going to give me a C. Say this 2 more times. We'll say if I ask for a B, give me a Z. If I ask for a C, give me a 7. Alright. So I'm asking for an A, which should give me C. Okay. I'm asking for the value associated with key A, really. So anyway, standard C out. We're going to say, yeah, I'll do standard line over here. I say the character is whatever. Okay. We're going to say C. That's the character I got from it. Let's try that out. Okay. Right, I didn't actually include map. So, I included vector before. This time let's include map. This will give us access to standard map. With some key type and some value type. This gives us standard vector or some element type, right? I'll say key for type. Okay. Yeah, character C. So I asked for the value associated with the character A, and it gave me that. But let's do a more complex case now. So this will be my test2 function we can call void test2. Alright. Boom. Okay. Let's do a map. Something like standard string. And that's going to give me a vector of characters. Right, so m vec, let's say named or something. And what I could do is say, what would be vector of characters? Let's say I have map of names to vec char, something like that. Map of names to vector of characters. So I'm going to say something like m names to vec char position, let's say tepid coder, right? Equals, and I can do standard vector some sort. I think I want to do this. So there's a reason I'm trying to mention this here. I'm just trying to think how best to say this without making it confusing. Whenever you access a map of any type, you just access a key. Like right now I'm referencing the key. What it's going to do is it's going to return the value associated with that reference. Now, because this doesn't exist yet, it's actually going to create that element for me. So it's going to create a element of this type that's associated with the string, and it's going to return reference to it. So it's actually creating a standard vector automatically, and it's returning a reference to that. So what it's going to give me is a standard vector char, so what this is, reference, right? That's what it's returning when I call the map with this subscript operator overload. So whenever I ask for that, it's going to return this. So that means what I can do actually is I can say things like dot in place back. I can say C, right? C for character. Let's say J, because my name is Jacob. What else? second. I just want to make this as clear as possible. So standard cout. Let's actually print this out. Okay, position 0, let's say. So I'm going to print the first character of that vector. I really don't like how this wraps to the next line. Oh, it's so annoying. Okay. Anyway, I'm showing this a really silly way right now, so I can get the easier way while you'd use the alias. So it's a J. Okay, but instead of that, what I can do is simplify this. So I'm going to comment these out real quick. Let's say I have n names to vec characters, right? Let's say the type of decoder. I'm going to say standard vector, type char. It's a reference. Let's call it v just for now. Now what I can say is v dot spec, and do that j again. I'm also going to say standard cout, and this time it's going to be v position 0. Alright, oops, wrong way. Standard line. Right. Let's try that. That should do the same exact thing. There it is, J. So in this case, it actually makes sense, right? Otherwise, every single time I want to add something new, I'd have to do, this out in place back, This time, maybe I'll do an A, and then do it again, and have C. I mean, obviously, I could do it all in one insert. If I do something like const char let's see, name equals, Jacob, right? In that case, I would do something like, do I still have it copied? I do. Dot insert, and then I do, in names to vec char, and then basic name, and then basic name plus 5. There's 5 characters in the name. Alright, so if I'm starting on J, A, C, B. So this is where I'm starting. But I'm going to add 5 characters to that. So right now we're at 0, 1, 2, 3, 4, 5 will be the first character after it, right? Like that. There's no actual 0 there, though, because it's a vector. It's just this vector has length. So I don't really need to store the 0, because it knows the length already. So I could do that, but I don't really want to have to type this everywhere. So it's nice sometimes to just reference the vector, and then be able to just say v dot whatever. So that's the main reason you'd use that. So the last thing I want to show, and this is really the whole point of the video, was to build up to this point. Let's move these into another one, void test3, let's just call it. Okay, paste that in there. So what I want to do is I want to make a class object. I don't know what I want to call it, something, it doesn't really matter what it does. The whole point here is just to show you how you might use a reference inside of a class, because this is a bit interesting. You can't do this until C++11. If you want to type reference like this inside of a class, you can't do it because these have to be assigned, and they can never be reassigned. Any kind of reference like this, once you've assigned it, like say I have char C and I have, I don't know, char R for reference, let's say reference type equals C, I can never reassign this. What I said earlier about how if you assign this, it's going to be the same as assigning the thing it references. So when I say R equals D, really what it's saying is C equals D. What I'm trying to say here is that you can't make it alias something else, right? There's no way to do that. And because of that, when you make a class object, what I call it, something, you can't, say what this is going to be, what this reference is, because you don't know until you create the object. So maybe you would think something like you could do, I don't know, reference is a character, right? It's nim C, right? C ref even, okay? Maybe you could do this, and you could say something, and you could say the default constructor is deleted. You can say something, destructor exists here, and then we're going to say something with a new constructor to create. This is going to take, why did I say C? I'm going to say char. This takes a character you're going to reference. Call it C. Okay, let's actually define that. So something, that's our constructor. Take the character reference. Okay, we're gonna say m, what do I call it? Ref c or something like that? What do I call it? Mref c, yeah. Equals c. This won't work, because it's gonna look like you're reassigning it. As soon as you construct the object, it has some default value it gives, and you can't actually construct it like this, because it's not assigned to anything. And assigning it in the constructor, you'd think that would work, because it's the time it constructs, it's where it's assigning it, right? But this isn't going to work. So something, destructor, comes from the something class, and it is the destructor, the same method. Okay. So here's where it destructs. I'm not actually going to do anything here. Something s. I'm just going to try and construct it. See what happens. Okay. So something, uninitialized reference number. So you can't do that. But with C++11, you can do this. There's something called an initializer list you can use. So we can leave this not actually referenced here, but we can't use the constructor in this way. This is going to happen after everything's been initialized up here. So if I set this to like some value, let's say it's not a reference, let's say it's actually a character, I set it to C, that's going to happen before this is called, I believe. Okay, well the initializer list will happen where it's called. Okay, anyway, so instead of doing this, assigning it right here, what you can do instead is you put a colon here, and you can start assigning your members. So what I'm going to say is mref c is getting assigned with c, which I'm passing right here. Okay, now it'll work. So, okay, use it main something else. Right, I used the deleted function. So the default constructor I deleted, remember? Right here. So you have to use this constructor. It's the one I've defined. So it's going to reference that. So what I want to do here is I want to say something like, well, first I'll let it compile. So char c, reference c. Let's let it compile, and I'll make it more complicated after that. Yeah, forget on that. So that compiles. So now what I want to do is I want to make a getter and setter method, something like c equals c. Let's not get. We're going to get that value, standard c out. We're going to say the character referenced by the class is, whatever it's going to be. Okay. Line, standard line. Yeah. Okay. Next thing I'm going to do is let's copy this. Let's say s.set. Let's set it to x. I don't know. Set it to x. And we'll print out again. In fact, what I'll print out this time is actually going to be the character that's being referenced. So I can show you that it's actually manipulating the thing you told it to. So we're going to do char get. Doesn't take any arguments. It's constant. Can't throw any kind of error. I could do a no discard if I wanted, but whatever. Anyway, void set. Don't take a char. C is not const. It is no except though. So let's copy these. Paste. So something's where it comes from. Something. Okay. Here we're going to say what was it? Ref c equals c. And that passed. And here I'm going to return mref c. I'm not returning char reference, so I could. That would mean whenever you call get, it's going to return a reference to it, and I can modify the value here. But instead, I'm just doing this. It's going to return a copy. Okay, so we're defining a character. We're assigning it to C, so it's going to be the character C. We're storing a reference to that in the class, so the class can modify it if it wants. And then we're going to print out that character by the reference to this. So the class is going to look up this address memory, and it's going to return a copy of that. Right here. Just a copy, not a reference. And when it gets that copy, it's going to print that to standard out. Okay, then I'm going to set the value at that address that I'm referencing to x. So C right here is going to become x, the character. And then I'm going to print C out, the character. I could also do get again, it would print the same thing. So let's show that. There it is, C then x. I probably should have put that in both cases afterwards. There it is, CNX. Anyway, that's how references work. And hopefully it makes sense why I didn't show this kind of reference until now. Like, there's not really many good reasons to alias another variable unless you're using classes and you're using initializer lists, or if you have some complex type like I showed in the third example with this map. You know, I mean, you can use it to make a name more descriptive, like with a vector, right? But more so, like with this map, I think it makes a lot more sense. I can actually, did I not save that example? Oh, here it is, okay. Right, so it's returning a reference to that type, the value type right here. So standard vector of characters reference, which is what I'm getting right here, calling it v. And then I can just alias it really quickly. Instead of typing all of this dot whatever every time, I just type this. Also, this is faster anyway, because every time you do this, it has to find the element associated with that key. So it's searching, you can imagine, these keys to find that value. It has a pretty fast algorithm to do that, but in worst case, it's going to be the number of keys, right? How many keys you have, it could have to search all of them. That'd be the worst case. Quickest case, it's going to instantly jump to it. And it uses something called a hash internally, and maybe I can talk about that later, but it's pretty quick to look up. But if I just reference the actual address of the element in memory, I can access that directly every time. You know, it's not going to have to look it up each time. So this is just going to be faster in general. Anything else I want to say about that? I think probably not. I think this is good. Anyway, as usual, if you found this useful, please like, comment, subscribe, leave some feedback, leave some criticism if you have it. If there's anything you didn't understand, maybe write that in the comments and I can expound upon it in a future video. Anyway, hope you have a nice day. Catch you later.